Okie dokie, part 2, let's go. Okay, so biomechanics, please let me forewarn you that the extent of biomechanics, just in general, that you need to know at the moment isn't really in depth. You just have to understand how the body works, how forces are applied to the body, and how we can use force within a sporting context and the effects that it has. So first of all, we talked about what is biomechanics. Okay, so biomechanics is the study of forces and the impacts that they have on the body. That's it. Okay, not overly complicated. We talked about the difference between displacement and distance. Okay, when we're talking about this one, we said, for example, somebody asked if I wanted to draw a picture to show you the difference rather than try and write an explanation. Is that okay? And I have no problem with that, providing it's clearly labelled. Don't draw me a picture and then I have to try and figure out what it means. Show me what you mean. If it's displacement, show me that there's a starting point A and there's a start and a finishing B, okay, and draw the line. So displacement is the distance between a start and a finish. Okay, remember we use the example of if you swim 1 lap of a 50-metre pool, your displacement is 50 metres and your distance is 50 metres. But if you swim 2 laps of a 50-metre pool, okay, your displacement is 0, but your distance is 100 metres. Keeping in mind that there's a minute and a half, so don't go nuts with your drawings. That really kills me that hasn't highlighted, but I guess I shall have to move on. Okay, we started talking about velocity and speed. Okay, we're talking about how velocity is just displacement over time and speed is distance over time. We didn't talk too much about that. That was really honestly all we talked about. Why did it work now? Fluid mechanics, okay. We were talking about, we were just talking about also other things like center of gravity. Okay, what is your center of gravity? If you need to draw me a picture for that again, that's fine. Okay, so remember that the height of the center of gravity is relative to the base of support. And on your slides, for example, you've got that person that's standing up straight on 1 foot or bending over. Okay, and the center of gravity is generally always in the middle there. Line of gravity is an imaginary line, okay, of where their center of gravity would be. If we drew a line, it would be down the middle. And the base of support, for example, if I'm standing up and my feet are separated, my base of support is the distance between my feet. Okay, that's what we talked about there. I wonder why I forgot to put that in my notes. In fluid mechanics, we just made the point that it's not just water. Okay, fluid mechanics relates to air environments as well. And the 2 key concepts that we would talk about there is buoyancy and drag. Okay, buoyancy is that force that enables you to stay afloat. Okay, and drag force is the force that is behind you that attempts to slow you down. So remember, we often used either the swimming, so when you're kicking, you'd be creating drag behind you, or when you're cycling, you would have that air drag behind you that comes off your helmet. Those are the things we're talking about there. I'm just looking at the slides to see if there was anything else. That was it. We had a quick chat about the Magnus effect. Obviously, everyone referred to it as the Magnus effect. Ha 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 ha. We were just talking about the effect of how the pressure of the wind against an object, how it changes its movement. When we're talking about forces, we have internal and external forces. Okay, so for internal forces, I stood up and I showed the guys that there is nothing acting against me, lies other than gravity, but there was nothing externally forcing me to move. But when I raised my arm, okay, that was an internal force. My muscles were creating a force and pulling against my bones. Okay, so my arm moved up. But then we talked about, for example, if Vav pushed me over, that would be an external force that made me move. That was all we focused on there. And then for Newton's laws, Athan was a machine. He rattled them all off in one go. Okay, so for Newton's laws, we've got 3, remember. So Newton's first law is the law of inertia. Okay, the fact that an object will remain at rest or in motion until another object or force acts upon it, causing it to stop. We've got the Newton's second law. Okay, so those of you that did 10 pass, you may know it as the law of acceleration, which is completely fine. In your notes, it says the law of force equals mass times acceleration. I'll accept that also. Okay, so we talked about the force being the effort applied. For example, when we're kicking a ball, the mass would be, I'm having the biggest brain fart, would be your foot against the ball, and acceleration would be how hard you swung your foot at the ball would impact on how far the ball moves. I apologise if I've got that jumbled. And then the third one, we have Newton's third law, which is the law of action and reaction. So for every action, there is an equal and opposite reaction. We bounce a basketball, okay, it bounces back. So the action is us hitting the ball onto the ground. The reaction is the ball bouncing back up. That's us off the ground. What else did we talk about at the end? We talked about just what the term summation of forces meant, okay, and we used the example of how if you're pitching a ball, you don't just kind of use your fingertips to throw it. It always kind of becomes a whole body movement where you rotate your arm around, you twist your body, you use your hips, and you step forward, okay? It's where one body segment influences the movement of the next part. Centripetal and centrifugal forces, okay? So there's a picture in your slides about the person swinging around the bar, okay? So the center-seeking force acts towards the center of rotation, okay? So that's a centripetal force, and that'd be your hands on the bar as the person went around, 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 and then their equal and opposite force that is applied, okay, which would be the bar, which is a centrifugal force. Again, please don't get too caught up in that. That's really it, guys. Go through PowerPoint slides. Please remember, although there's probably more than one part to a question, okay, you've got a minute and a half, so I'm not going to ask you to write an essay or to do anything overly elaborate. Have a look through, have a listen. I'll get these YouTube clips up and we can go from there. Have a glorious afternoon.